Okay, so on the last video, we looked at linears, the type of solutions they're going to have, and what the end behaviors look like. We're going to focus on specifically on the roots or the x-intercepts on this video here. So again, just reminder that if you have a constant term, that would be like your f of x equals 3 on there, then you're not going to have any x-intercepts, okay, at all. It's because you're going to have a horizontal line. The only time you would have one is if it was f of x equals 0, in which you were the x-axis. Your linear functions, I'm going to go ahead and put it in, even though this is not standard form, but this is the form most of you like it in. Again, it's possible you're going to have one x-intercept, and it will be a real root. Okay, so we could find one. Then you've got your quadratic function. And a quadratic could have a max of 2. And so we talked about how you could have 2 real roots. I'm actually going to make this into a table here for you, because that's how we'll do when we go to look at it earlier. We're going to talk real and imaginary. Okay, so you could have 2 reals and 0 imaginary. That's when it would cross at the x-intercept, or you would cross your x-axis twice. You could have 0 real and 2 imaginary. Again, that's when it doesn't cross your x-axis at all. Okay, we've got our cubic function, which has a max of 3. And when I go to look at this one, okay, and we're going to have to remember a couple things, real and imaginary. So again, if I had, whoops, I don't know what happened there. If I had 3 real, I would have 0 imaginary. That means it would cross 3 times. If I look at it, and remember we talk about imaginary comes in pairs. So this can only go 0, well, sorry about that, guys. 0, it could be 2, and it could be 4. So I could have 3 real, 0 imaginary, or I could have 1 real and 2 imaginary. Okay, again, because my imaginaries come in pairs. You got to always remember that. So over here in this column, guys, you will never have an odd number. Okay, because they always come in pairs. And so what we're really looking at is just any combination that adds up to 3. In this case, any combination that adds up to 2. And so, you know, I couldn't have 3 over here. So those would be my 2 choices. Either it's going to hit 3 times or it's going to hit 1 time. Okay. And then I'm going to go on. So if we have a quartic, okay, just to show you how it works, ax4 bx cubed cx squared dx plus e. Again, it's going to have a max of 4 on there. And when I divide it up into my reals and my imaginary, first off, I could have all 4 be real, crosses in 4 places, no imaginaries. Could I have, is my question, could I have 3 reals and 1 imaginary? Is that possible? Hopefully your answer is no, because I have to have just evens over there. So that is not a possibility. A lot of times I'll mark it on there just to see if you pay attention, and then we'll mark through it. So the next would be I could have 2 reals and 2 imaginaries. Yeah, that works because my imaginaries come in pairs. Could I have 1 and 3? Again, hopefully your answer is no. And then the next would be 0 and 4. So you see how I'm writing all the different possibilities there. Now, do you need to write the 1 and 3 and 3 and 1? No, hopefully you understand that those are not possibilities. So there's really no reason to even write those in there to start off with. Okay? But I will have some people who don't realize that they're not possibilities. Okay? So those are your types of graphs you may have. 4 real answers, 2 reals and 2 imaginaries, no real, 4 imaginary. We do not usually get the 0 and 4 because it's almost impossible in Algebra 2 to find the 0 and 4. Okay, that's higher level. Okay, our last one we're going to do is the quintic, which is just 5. So ax5 plus bx4 plus cx3 plus dx squared plus ex plus f. Whew, that gets long. 5. Again, let's look at our possibilities. So real, imaginary. So I have a total of 5 and 0. It's always what we're going to start with. So again, it might be easier to start over on the imaginaries because I know I could have 2. That would be 3. I could have 4 and 1. See, so these always have to go with. And next would be 6. That's not possible. So those are my 3 possibilities of what my graphs could look like. I could have 5 answers. I could have 3 real answers and 2. I could have 1 and 4. And I'll try to give you examples of all of these when we're graphing to point those out. Okay, so that is looking at all the possible types of roots you might have. It's called the fundamental theorem of algebra. Okay, so you kind of know ahead of time what you're looking at.